Here is the quotient rule introduction video. The most important thing to know about the quotient rule is what the quotient rule is. That's this guy right here. It should seem very similar to the product rule, except we use the quotient rule when we're trying to take the derivative of one function that we know its derivative divided by another function that we know its derivative rather than multiplied by. So here would be an example where we could apply the quotient rule. The quotient rule is a little bit uglier than the product rule, a little bit harder to remember than the product rule. I hear there's like a jingle that you can sing to help you remember it, but I don't know it, and even if I did, I would not sing it and record myself singing it. But it's not too horrible, I guess, but this would be a good thing to throw down on a note card or something. Make sure you have it memorized because it'll come in pretty handy. So the way we'll apply it will be really similar to the way we applied the product rule. It tells us how to take the derivative of something divided by something. So up here in the numerator, this 3x plus 7, we can call that our f. And in order to make things match up with the formula we have as much as possible, we would call g what we have in the denominator here, namely x squared. And the nice thing about those guys is they're two relatively simple functions. We can take both of their derivatives just by looking at them. The derivative of 3x plus 7 is just 3. The derivative of x squared is 2x. And now that we have these pieces, we have everything we need to figure out the derivative of this guy. The derivative of 3x plus 7 over x squared is, according to our formula here, f prime, 3, times g, x squared, minus g prime, 2x, times f, 3x plus 7. And that whole thing divided by g squared. G is x squared, so we have x squared squared. So this is the derivative. Again, it's probably not a bad idea to simplify a little bit. We could rewrite this as 3x squared minus, distributing this negative 2x through, we get minus 6x squared minus 14x. Be careful with that. A common mistake is just distribute 2x through, not the negative 2x. Make sure you don't forget this negative sign right here. And that is divided by x squared squared is x to the 4th. When you have exponents raised to exponents, you multiply them. 2 times 2 is 4. And 3x squared minus 6x squared, we can combine like terms here and call that negative 3x squared minus 14x over x to the 4th. We could even go one step further and cancel out an x from the top and the bottom, leaving us with negative 3x minus 14 over x cubed, which is pretty good and simplified. That gives us this derivative. Maybe it's instructive to show another way to solve this problem. If you do a little bit of work beforehand, you can save yourself a lot of work when you're actually taking the derivative. And what I mean by that is another way to think about this problem is 3x plus 7 over x squared is the same as 3x over x squared plus 7 over x squared, which, if we cancel out an x here and here, we have 3 over x, which we could write as 3x to the negative 1 power. And over here we have 7 over x squared, so 7x to the negative 2. And the advantage to this form is we no longer have any fractions going on. We don't have to use the quotient rule anymore. We can take this derivative just by looking at it. Special rules to use. I guess it's the power rule in here, but that's one of the more basic ones. You take the exponent, the negative 1, and multiply it times the 3. Negative 3x, and then negative 1 minus 1 more gives us negative 2. And similarly over here, the negative 2 times the 7 gives us negative 14, x to the negative 3. And if we do a little bit of algebra here, we can get this answer to match up with this answer. Negative 3 over x squared minus 14 over x cubed. Multiplying this term by x over x gives us negative 3x, and we'll have a common denominator of x cubed. So sure enough, the answers match up. So in this case, you can get away without using the quotient rule, but there'll definitely be cases where you have to use the quotient rule, so it's a good one to remember, and here it is.